The United States, of course, has many well-known international symbols, the White House, Statue of Liberty, Mount Rushmore, the flag, but really only the last of those, the flag, is mobile, can actually show the flag, as they say, around the world. Would you think it's fair to say that Air Force One also represents a mobile symbol of the United States? Is that fair?
Yeah, well, I know you've been on Air Force One, and I'll tell you, when you taxi up in our country or in some other country, there's a great emotion about it. And it's, I loved, when I go up to shake hands, at the rope line with some kid, say, was that exciting to see this? Oh, and you can really tell that they were moved, and the teachers bring the kids to see it. So it has a symbolism that projects. It is a symbol. It is a mobile symbol of the presidency and thus the country.
Even now, many people tend to overlook a plane that has quietly revolutionized the concept of international travel, the Boeing 747. Individuals like the late Wan Tripp, the former president of Pan American Airlines, foresaw its potential right from the beginning.
Wan Tripp came to Seattle to sign the contract. It happened to coincide with the 50th anniversary of the Boeing Company, and he was the guest speaker at a large banquet downtown. And so he gave this speech on the 747. And he was a very idealistic man anyway. He'd started more or less international travel by, spawning Pan Am from the days when they were prop airplanes flying and so forth. And he said, I think that the 747 is a great weapon for peace, and it's really competing with the intercontinental missiles for man's destiny, which sort of surprised us all. And he thought it was going to win. And he explained that when you got millions of tourists flying back and forth between countries, and they were exchanging their goods and produce and products and so forth, that you'd learn to like each other before and do business with each other before you blow them up, I suppose. And turns out that he's pretty close to right, because 20 years later, we're bringing out a new airplane, the 747-400 version. And that year, Reagan and Gorbachev have decided to scrap missiles. And so, and we're doing it's a trillion revenue passenger miles to be flown in 1989. So Wan Tripp was really a prophet.
On August 16, 1989, in Sydney, Australia, a new Boeing 747-400, the latest iteration of the 747 series, landed at Sydney International Airport. Covering 18,001 kilometers from London in an impressive 20-hour, 9 minute, and 5 seconds, it marked the longest non-stop airline flight in history. This achievement became a significant milestone in the world of travel during the 747's 21st year. However, the remarkable story of the 747 begins far from Sydney, Australia, both in space and time. On July 16, 1916, in Seattle, Washington, William Edward Boeing established the Pacific Aero Products Company. As the USA entered the war against Germany in mid-1917, Bill Boeing secured an order for 50 of his Model C trainers. By the end of the year, Pacific Aero Products transformed into the Boeing Airplane Company. In March 1919, Bill Boeing and his pilot Eddie Hubbard pioneered the first international mail flight covering the route from Seattle to Vancouver. By 1928, the Boeing 80A represented the pinnacle of travel comfort, introducing the first flight nurse or air hostesses. Improvements in the metal fabrication techniques ushered in a series of metal-skinned, low-wing monoplanes, exemplified by the XP-9 bombers. By 1934, when Roscoe Turner completed a journey from London to Melbourne, Australia, aboard a Boeing 247, a genuine revolution in passenger air transport had unfolded. In 1933, the 247 significantly reduced the U.S. transcontinental flight time from 27 to 19.5 hours. Fitted with twin Pratt Whitney Wasp engines, it outpaced other airliners of the period by 50 to 70 miles an hour. Despite its groundbreaking design, the success of the 247 was short-lived. When TWA sought a competitor, the birth of the DC series at Douglas rendered the 247 nearly obsolete, especially with the introduction of the DC-2 and DC-3. Undeterred, Boeing shifted its focus to size, unveiling the 4-engine XB-15. It was the first really big plane to use state-of-the-art technology in streamlining and high-performance power plants. Only one XB-15 was built, but Boeing had established itself as a manufacturer of big aircraft. When Juan Trippe of Pan American Airlines approached Boeing with the idea of constructing a large flying boat for intercontinental passenger routes, the XB-15's engines and wing design were repurposed to fit the new hull, giving rise to the Model 314 Boeing Clipper. The Clipper boasted impressive dimensions, with a gross weight of 82,500 pounds and a payload capacity exceeding 15 tons, encompassing fuel, passengers, and cargo. Priced at $700,000 each, the construction of each Clipper demanded 350,000 man-hours, representing a significant stride toward Juan Trippe's vision of an affordable international travel system. The Clipper facilitated regular scheduled transatlantic services with its extensive range and the ability to accommodate 2 shifts of flight crew. Concurrently, Boeing pursued a different trajectory, aiming upward. Building on the concept of 4 engines and a more compact fuselage than the XB-15 for enhanced performance, Boeing had crafted Project 299, the prototype of the Flying Fortress B-17. This innovation culminated the 4-engine Stratoliner, characterized by a cigar-shaped pressurized fuselage. Equipped with a supercharger to supply oxygen for high-altitude engine performance, the Stratoliner also delivered pressurized air to the cabin. It wasn't the first 4-engine airliner, but it was the first pressurized airliner to enter service. One Trippe from Pan American ordered 4 Stratoliners and TWA ordered 5. The inaugural flight of the first Stratoliner took place on December 31, 1938, generating considerable excitement due to its capacity to reach 26,000 feet and accommodate 33 passengers. However, despite its promising prospects, setbacks emerged. A significant crash involving Stratoliner No. 1 prompted the addition of a dorsal fin to enhance stability. The outbreak of World War II interrupted the trajectory of international travel development. Nonetheless, advancements in supercharger pressurization and later turbo superchargers contributed significantly to Boeing's line of large bombers. The production of 12,000 B-17s played a pivotal role in the Allied war effort, not only in bomb deployment but also in air combat, surpassing the combined enemy plane victories of all other American warplanes. The subsequent introduction of the B-29 Superfortress, featuring a pressurized fuselage, marked the pinnacle of World War II bombers. Its historic impact culminated with the deployment of the bomb that brought an end to the war. Post-war, its transport variant, the C-97, evolved into the Stratocruiser, representing Boeing's ultimate achievement in large piston-engine international airliners. In 1945, Boeing's new president, William Allen, recognized the imperative for the company to re-enter the civil aircraft production. He took a bold gamble by announcing the construction of 50 Stratocruisers at $1 million each. The Stratocruiser epitomized luxury and international travel during an era predating the introduction of economy and tourist fares. Its standout features included a spiral staircase leading to the lower deck lounge, providing passengers with the opportunity to stretch their legs and enjoy a change of scenery. Additionally, the ladies' lounge offered a convenient facility for maintaining in-flight appearances. The Stratocruiser's major competitors at the time were from Lockheed and Douglas. They were like this constellation, essentially pre-war designs. There were also other planes like the British Hermes, flying the international routes. Post-war international air travel did not experience the anticipated boom, leaving the luxury of crossing continents at any time of the day or night accessible only to a privileged minority. In May 1952, the British de Havilland Comet initiated a service from London to Johannesburg, but its introduction to the transatlantic run faced challenges. The trajectory of jet international travel received a boost with the necessity for a new in-flight tanker. The Boeing KC-97, suitable for refueling piston-driven planes, proved too slow for the emerging generation of long-range jet bombers. The B-47, with 6 General Electric J-35 turbojets, took flight in 1947, setting the stage for the next generation. The B-52 Stratofortress, designed to meet the demands of a global defensive weapon with extensive flying ranges. An efficient in-flight refueling system became crucial, leading to Boeing's bold move. The Dash 80 was a novel design with a low-wing and swept-wing monoplane, equipped with 4 Pratt Whitney J3 engines, initially served as the KC-135 tanker. However, it diverged from its military destiny, evolving into the Boeing 707, the United States' inaugural international jet airliner. The introduction of DC-8s from Douglas on transatlantic routes alongside the 707 marked a turning point. Passengers' numbers surged by 12% annually, prompting Douglas to unveil a stretch version of the DC-8 to meet growing demand. While the 707 faced limitations in stretchability, fate intervened with the U.S. Air Force's competition for a large transport airplane, the C-5A. Boeing, renowned for constructing larger aircraft, enthusiastically entered the contest, dedicating a design team of 500 men to the project in June 1964. The company, drawing on its vast experience in building large planes, was considered to have an advantage over competitors like Lockheed and Douglas. But a year later, in September 1965, the word came out. Boeing, with all its knowledge of big plane construction, had quoted too high of a price, and Lockheed had won the contract to build what became the C-5A Galaxy. However, what initially dealt a blow to Boeing turned out to be a pivotal factor in the future of international jet travel.
When you're competing on something as large as the C-5A, if we had won that contract, it would have absorbed a great deal of our energy, and we probably would not have gone forward with the 747 at that time, and then later. However, the fact that we lost it, and that released a fair amount of energy and resources to do something else, we were anxious to get moving, and it, in a sense, probably accelerated our going into the 747, which it turned out to be a very attractive decision.
The conception of the 747 emerged from extensive consultations with airlines worldwide, and Boeing President William Allen played a crucial role in endorsing the construction despite the absence of firm orders for the plane. Pan American Airlines, with a significant history tied to Boeing's aviation milestones, including the Clipper, Stratoliner, and Stratocruiser, once again played a pivotal role in shaping Boeing's destiny.
Well, Juan Trippe got intrigued in it, and Bill Allen and the two himself, they said, well, what about it? And our designers said, we can design and build it. And he said, if you can build it, I'll buy it. And between the two of them, they struck sort of a deal that they sort of sealed with a handshake. If we would go ahead, I believe the timing this was in February of '66. If we'd agree to build the airplane, that he would buy it. We said, well, we'd have to have orders from at least 3 airlines for 50 aircraft. And if that was the case, we'd go ahead in August 1st of 1966. At that time, we did not have signed contracts, I believe, for the 50, but we were close enough and we were already enraptured with the concept, so we went ahead. I believe that Juan Trippe, in order to ensure that we were serious about it, more or less bet Bill Allen $10 million that he wouldn't go ahead. It wasn't so much a bet. I think it was a if you didn't do it, you'd have to pay the money. But we did go ahead, so we didn't have to pay the $10 million.
On July 25, 1966, the Boeing Company decided to convert this forest into one of the biggest manufacturing complexes in the world. The company decided to erect here the largest factory, volume-wise, ever built, in order to assemble the largest commercial jet airplane in aviation history. The plane was the giant 747, 6 stories high, 231 feet long, with a wingspan wider than a football field. 2 1/3 times larger than a 4-jet 707. At the time, for the first plane, only 31 months go ahead to roll out. But for the factory, time compressed even more. 9 months until fabrication of the first part, or the first plane, had to begin. Challenges of the factory came first. Challenges posed by the necessity of building that first part on time, of keeping one step ahead of the growing plane.
Clearing timbered hilltops was necessary to make room for the factory, and a massive landscaping effort transformed 630 acres in Everett, approximately 40 miles north of Seattle. Over 250 contractors, subcontractors, and material contractors were involved in the project, with a contractor labor force of 2,800 men representing nearly every construction craft in the area.
Well, as far as a financial risk or a business risk, it was, you'd have to say it was awesome, I guess, because obviously what the money it took to develop, design, and build the prototype airplanes and then build a production rate up was far in excess of the net worth of the entire company. So we were betting the company on the success of the airplane.
The railroad, second steepest in the nation, lifts trains as high as Seattle Space Needle, more than 500 feet, from Puget Sound to factory level in less than 3 miles. Speedy construction of the $2 million railroad was essential. The line would be required initially for hauling material to the construction site, and later for moving parts and equipment to factory assembly lines.
We threw many men and much equipment into that gulch in order to build that railroad. It was tough to get the ballast down and to get the tracks laid. It was not that we could never do it, but we were able to bring it out on schedule.
The head of facilities for me, a fellow named Bain Lamb, that was building this world's largest building, he used to be a quarterback on the University of Washington Huskies, and I had been a guard at Georgia Tech, and he never liked taking orders from a guard anyway, but he came to me one day and he said, we're not going to get that on time. And I said, the devil, we're not, what do you need? He said, well, I need more people. And I said, you've got them. And then he said, I need more equipment, our earth moving equipment. I said, you've got it. And he said, I need more money. He said, don't bother about it. We'll get it for you. And he said, I need 2 weeks of clear weather. And I said, you've got it, And then, because it turned out God got even because it rained 67 days in a row.
There were always problems. No sooner had clearing begun than rains swept the site. Equipment mired down.
When we found that this glacier till that is so hard also turned out grease. We couldn't work, obviously, in the mud, so we paved about 100 acres under the buildings. Then we were able to work out of the dirt and out of the mud.
Size and speed of the project demanded rigid controls at every turn. As Director of Facilities, Bain Lamb explains,
every single thing that goes on in the project is scheduled and planned in this room. We can tell in an instant whether or not we are ahead or behind schedule.
Overcoming the challenge of job overlap between construction workers and aircraft builders was one of the major hurdles for the planners.
The contractors we knew were going to be in the area adjacent to our people, overhead, in the structures, in the towers, underfloor, in the trenches and the ducts. At the same time, Boeing people would be trying to produce the parts that would later go into the airplane.
Simultaneously, Joe Sutter, the chief project engineer for the 747, and his team spent over a year finalizing the plane's design to ensure that a mock-up construction could commence promptly once the building was ready, or if necessary, even before that. As soon as it became feasible, construction crews transitioned inside. While interior walls were being installed, activity continued outside on the roof. Electricians worked indoors, stringing cables, while steel workers outside completed the walls of the mock-up building. The building was scheduled to be occupied in midwinter, specifically in January 1967.
We realized early that we were not going to be able to turn over a completed facility. It would be not heated, would be wide open on one end, the floors would still be curing out. A shell is about all we had to deliver. They were wearing gloves and their mackinaws, their hard hats.
They were very, very motivated. The workforce, there was no need to try to energize them. They were on a very romantic task. They're building the world's largest airplane. And they would, we had people that would drive all the way from Tacoma, which is 70 miles away, to get to Everett to work on the aircraft. They had an enthusiasm that welled up, and finally someone coined the word that they were the Incredibles. And trying to think of who decided, but they got Paul Bunyan insignia and put it on their hard hats. They had to work on hard hats because the building was still under construction, and on their lunch pails, and they had them on their jackets and what have you. And they really did a yeoman's job. Yeah.
it was incredible. And the Incredibles is what they were called.
The railway from Puget Sound to Everett ran up its steep incline right into the factory in order to bring the literally millions of parts of the plane together in the right place at the right time. The factory was virtually a city in of itself. It was the world's largest building in cubic capacity, covering 43 acres under one continuous roof. The facility housed thousands of workers and boasted its own food and medical facilities. Resembling a stage as vast as the 40 football fields, eagerly awaiting the arrival of its principal player, the player whose lines had been meticulously polished and refined over many months by a dedicated team, aimed to ensure that everything would be flawless when the curtain rose on opening night.
whole job started way back down the line when engineers were still looking at paper airplanes and models, and wind tunnel testing began.
Our people devote literally thousands of hours of their time, and both on paper and in the wind tunnel, to minimize drag, because drag is money. Drag costs weight, drag costs fuel.
During the early development stages, Joe Sutter and his team explored nearly 50 different potential shapes, including a double-decker mid-wing configuration. Wind tunnel testing, costing millions of dollars, rigorously measured and recorded every aerodynamic parameter. To power the 747, Boeing sought an entirely new engine, securing one from Pratt Whitney, who had been working on a similar but smaller concept for the C-5A competition. The high bypass ratio engine, an evolution of the fan jet known as the JT9D model, delivered 43,500 pounds of thrust, equivalent to 87,000 horsepower. Pratt & Whitney tested the engine using a leased B-52 from the Air Force, modifying it to replace two of the B-52's standard engines with the JT9D. In the flight test program, the B-52 reached altitudes exceeding 45,000 feet, and under extreme conditions, the engine received a clean bill of health. The Praying Mantis, a device designed to simulate the experience of taxiing the 747 from a cockpit positioned 29 feet above the ground, played a crucial role in preliminary testing. Jack Waddell, the 747's chief test pilot, actively participated in this testing, demonstrating remarkable precision by parking it next to a cargo dock with a tolerance of plus or minus 6 inches with practice. It proved to many 747 customers that a huge plane would not be an uncontrollable horror around airports. The prospect of emergency evacuation from an unusual height was also faced in the early 747's development, and pilots were given an opportunity to fly in a simulator that used a remotely controlled TV camera scanning an accurate terrain model. In the simulator, the pilot wielded control over speed, altitude, and attitude, aiming to closely mimic the behavior of the actual plane as predicted by the designers. The full-scale mock-up of the 747 served as an engineering tool, systematically testing every part and system destined for the completed aircraft. This meticulous process was essential to ensure the seamless fit of all 4.5 million pieces in the intricate jigsaw puzzle, sourced from numerous subcontractors spanning various locations inside and outside the US. The successful assembly of such a colossal jigsaw puzzle presented substantial planning and logistical challenges for the management team. They had to meticulously orchestrate the accurate placement of components in the 43-acre floor of the Everett factory in Washington State.
As you know, there's literally millions of pieces in the airplane and parts, and they were coming from almost all of the 50 states and 17 foreign countries, and so that you had a tremendous logistics problem to get all of these designs and parts and schedules to mesh to bring together a line that was finally going to end up to being building a 747 every 3 days, roughly. They're on a 7-a-month schedule, and we work, as you know, 22 days a month. So it was a tremendous, problem and complexity, and computers weren't really available in the same dimension they are now, and so we were doing a lot of this with older techniques, and so it was an awesome job to keep track of the parts and make sure everything got designed right and tested and put into the airplane.
Given the project scale and innovation, new materials and engineering techniques had to be designed and developed. A large machine shop was established in Auburn, south of Seattle, to craft precision tools and massive jigs that couldn't be produced elsewhere. Without such innovations, economically viable manufacturing of the 747 would have been unattainable. Now, the pivotal moment arrived. The assembly of the 747 No. 1 commenced. The nose section arrived from the Boeing plant in Wichita, and the significant pieces of the jigsaw puzzle started to converge. The systems, initially designed in theory months prior, were now undergoing practical tests, and the trials were exceptionally rigorous. During this phase, the tolerances demanded of the engineering process were the most precise ever required in the aircraft industry at the time. The level of tension on the factory floor mounts. These people have committed themselves fully to the project, and now, the 747 No. 1 is beginning to emerge as a whole plane from the sum of its millions of parts. The tail, the height of a 6-story building, many times higher than the altitude reached by the Wright brothers on their first flight, is lowered into place. From the tip of the tail to the tip of the nose, it is also longer than the distance flown by the Wright brothers at Kitty Hawk in 1903. Even with the fuselage and wings assembled, the building process is far from complete. A Boeing 747 comprises 135 miles of wire, much of which was to be meticulously fitted by hand. The full project required the use of 75,000 engineering drawings, and strict adherence to assembly instructions was imperative. The 747's hydraulic system is intricately designed, incorporating safety backup systems to compensate for any potential failure. Coordinating the assembly within the allotted time was an immense undertaking.
I can remember it being a all-encompassing job. We spent 365 days a year working on it, and 7 days a week. I think we would have averaged something like 12, 14, 16 hours a day. I mean, the management. Some people said, I don't understand how Boeing can put an airplane out in 4 years. Well, another way is we did it in 8, but we crammed it into 4. It was a compelling job, and everybody that worked on it was sort of swept up into the enthusiasm for doing it.
26 months ago, as we stood amidst the forest up here at Everett, and the decision was made to go forward with the 747 program, the magnitude of the task that we were faced with really looked formidable.
On Monday, September 13th, 1968, Bill Allen witnessed his vision realized.
We have an airplane now, a remarkable one. Let us move forward to see it in service on the airlines.
And now, let's see the airplane.
Those present on the day recall that, initially, the plane didn't appear very large until it drew closer.
26 stewardesses, representing the 26 airlines that have ordered 158 747s, take part in the christening ceremony.
If you haven't got a bomb, raise your hand.
Organizing the christening may have been Malcolm Stamper's most challenging management task.
All right, now we're going to christen her, as you know, on the count of 3. Don't do it yet, but on 1, you're going to pick the bottle up. 2, over our shoulders. 3, all the way down. Okay? Now the cadence, so don't break it yet. The cadence is going to be 1, 2, 3. Got it? Okay, wait! All right. We'll do it again. 1, 2, 3. Magnificent. Well done.
The 747, in order to get it ready for the traveling public, we really torture the planes. We build 2 airplanes that we destroy in the process. One of them we call a fatigue test airplane, and we actually put it in a harness and fly it for the equivalent of 30 years, let's say, 60,000 hours. And we make it take off and land, and so forth and so on, over and over again. And anything that fails or breaks over time, we fix and then put it into the production line improvements. We also take the airplane and break another airplane and break it up in pieces. We want to know what it takes to break a wing. If you take the wing of a 747, you can deflect it 29 feet at the tip before it breaks. And that's quite a scene to watch it when it finally lets go. I mean, it sounds like an explosion. We break the tail off. We go through a complete destruction of the airplane, finding its real strength. We have all sorts of difficult tests. We'll take the 747 and purposely drag its tail on the runway to make sure that it will take off in that mode if the pilot over-rotated the airplane.
The VMU tests determine the maximum performance of the aircraft at the takeoff configuration. They're performed by placing the tail section of the aircraft in contact with the runway until the airplane lifts off. Speed at which it lifts off is called the minimum unstick speed, or VMU.
So the BMU then determines basically the takeoff performance of the aircraft. It also determines the ability of the airplane to tolerate inadvertent abuse. In the case of the 747, it's impossible to abuse the airplane enough so that it doesn't lift off cleanly with very good flying qualities.
We actually do a rejected takeoff test where we lock the brakes and freeze out the anti-skid devices. What happens is the brakes are locked, so the tires actually burn off, and it actually burns the wheels off, and it sits finally, and it catches fire. And you have to sit in the plane for 5 minutes without touching it. The fire trucks are there to see if passengers are there. They have time to get off, and then you're allowed to put out the fire. We paid the pilots a little extra for this.
During these high-speed flutter tests, the airplane was shown to be highly stable, and we reached Mach number speeds of 0.99, which is 99% of the speed of sound, and as high as 685 miles per hour, true airspeed. The 747 has a landing gear that is forgiving, and whereas that rate of sink in another airplane might have felt like a moderately hard landing, or 747 that will feel soft. I think it's a very forgiving airplane on landings. All our airplanes, we have a system on connected to the brakes that makes it possible for the pilot to apply brake pedal and not worry about skidding the wheels and then blowing some tires. This protective system is on all our airplanes, and on all our airplanes we demonstrate the operation of the airplane during landings and during refused takeoffs, with the system working and with it in various failure conditions. One failure condition is with two wheels not connected to the anti-skid system, and then we also check it with all wheels not protected with the anti-skid system and try to show performance of the airplane under these conditions. I thoroughly enjoy flying the airplane. I get a big charge out of it and enjoy it. It has no bad characteristics. It's an honest airplane, and I'm not just saying that from a sales standpoint. I think it's really a good airplane from a piloting and also from a passenger standpoint.
When you get in the airplane, it does seem very high up. Your eye level approximately 27 feet high above the ground. However, you've got very good visibility looking down, so you can see very close to the nose of the airplane. As far as taxiing, it's much easier than, say, a 707 to taxi. After taxiing around for a little bit, or even the landings or the takeoffs, it seems very normal, and the other airplanes seem like they sit too close to the ground.
On December 30th, 1969, following the flight testing period, Federal Aviation Authority officials arrived to pass judgment on the safety of the aircraft. For Boeing executives, a revolution in world transport awaited just a signature away.
You know, the airplane doesn't take very long to mature. So it's a big screw, really. I did sign the airplane flight manual there. I'm going to sign now the production certificate, the production limitation record. This includes the final certification for the 747.
The outcome of this effort is that we find the Boeing 747 as meeting or exceeding the safety standards developed and experienced of the Federal Aviation Administration. As a result of this effort, which included some 1,500 hours of test flying, we are convinced this airplane meets or exceeds the standards for safety evolved in civil aviation history. We therefore recommend the Boeing 747 receive the FAA type certificate.
The mostest of everything describes the new giant of commercial aviation, the jetliner 747. Contrasted with great conventional aircraft, the 747 will carry 490 passengers. This is more than double current capacity. Its engines will be twice as powerful as today's airliner. An idea of the size of the engines is emphasized by two stewardesses perched on the rim of a jet. Stepping inside the cabin is like entering a small theater. Pilots, stewardesses, and a passenger or two provide realistic perspective relative to passageways and rows of seats as they conduct an inspection of this mock interior. The first of these great birds, 25 in all at a total cost of $525 million, will be delivered by the Boeing Company to Pan American Airways in 1969.
With the 747 now in service, the factory shifted into full production. However, development continued, and within a year, the first new model, the 200B, took to the air. The only apparent external change was the number of windows on the top deck, retaining the basic 747 look and its user-friendly approach to spanning the world's skies. Even before the production lines began to roll, another critical aspect of construction had to be addressed: interior design. The demands of various client airlines for interior design could vary widely. This Air India version from the mid-70s represents one of the more exotic approaches to interior decoration. Before any 747 can be painted, it has to be wheeled over the freeway next to the Everett factory to the paint shop. It's a challenging sight for any passing driver unfamiliar with the area. Masking the fuselage surface is a highly intricate task. For any white-topped version of the plane, more than 70 gallons of paint may be required, and the levels of decoration can vary significantly. In first class, decor can range from simply functional to highly romantic.
I think at last count we may have been building 9 or 10 different models of the 747 because you need them for different things. For instance, the Japanese, who had a regional link stage route for the planes, flying between their various provinces, wanted a plane that took off and landed quite frequently. So we went in and changed the landing gear and the flap system to accommodate that. We called it a short range 747 SR. People wanted to fly freight and passengers, and so we made a part of it. We put cargo doors on the side and allowed them to put large containers into the aircraft. We had people that wanted to fly nothing but freight, so we built freighters where we open the nose of the airplane up and you can load these 8 by 8 foot containers that would be the size of a huge truck trailer into the aircraft and fly it, and that has become a large business. We had a plane, the Pan Am wanted to fly longer distance, farther and faster, so we wanted one that would climb higher and have higher speeds, and so we built an SP, Special Performance it was called, and we took a section of it out so it was a shorter airplane.
So, what's the significance of the number 747 and 747 SR, 747 Combi, and 747 SP?
Well, Boeing has always had sevens in their aircraft numbering. B-17, even the the B-52. If you add 5 and 2 together, you get 7, I guess. So that may be a little bit of mystique. And we had built a 707. Which, by the way, had 4 engines, and then built a 727, which had 3 engines, and a 737 that had 2 engines. So you can't make any sense out of this, except 747 was next in line for the number, and so we used it. For 747 has 4 engines.
In 1983, the 747-300 entered into service, introducing an elongated upper deck that allowed airlines to add up to 44 economy seats on that level. The 747 had evolved into the most recognized airplane globally, sparking a complete revolution in international travel.
747, and we talk of it in cents per seat mile, but it's inexpensive enough now to make it open for everyone. Everyone can fly today.
This revolution extended to airport infrastructure, with terminal design requirements expanding to accommodate the growing number of people on the ground. Traditional stairways gave way to air bridges, and baggage carousels became ubiquitous. The plane has had an immense influence on the way people perceive world travel. Since 1968, it has pulled the continents closer together and dramatically increased the number of people who look at world travel as an everyday and readily affordable fact of life. For about 50 years, the Boeing 747 has carried 4 billion passengers in several space shuttles. During the development of the 747, concerns were raised about its potential to overload airport passengers and baggage facilities and overstress runways and taxiways. While addressing passenger-related challenges took some time, the 747 has proven not to be hard on airport surfaces. It places no more stress on the runways than a 707, and despite accidents in the air, the overall safety record of the plane is excellent.
What started out as our greatest risk turned out to be our greatest reward. The 747 has been a marvelous product for Boeing and for the flying public. It's exceeded our fondest expectations. It's been very effective for us, profitable for us. It's allowed us to have the resources, if you will, to gain the resources to build new airplanes, the 767, the 757, very advanced designs. It's allowed us to put those kinds of improvements back into the 747, and as you'll notice, it has winglets on it now. And of course, if you could get inside the electronics, you'd find it was all digitized, very modern aircraft. So it's what looked like a really big gamble turned out to be a really big gain.
The 747-400, an improved version of its predecessors, boasts several enhancements. Rolls-Royce, Pratt Whitney, and General Electric provide more powerful engines. With an 8,000-mile range, the 747-400 enables non-stop flights on legs such as LA-Hong Kong, London-Tokyo, and Singapore-London. Tilted winglets improve fuel burn by approximately 3%, contributing to the improved range. Digital technology has played a crucial role in simplifying controls. Now, a flight crew of 2 can handle the plane with no extra strain, showcasing advancements in efficiency and ease of operation for the 747-400. New generation materials have allowed weight reduction while at the same time increasing strength.
We originally started out, we estimated there might be 600 747s, built in time.
Indeed, the 747 has become a familiar and enduring sight in the skies. Its longevity is a testament to its durability as an aircraft.
The 747 was a great challenge for me, obviously, and as I look back on a career full of interesting and wonderful challenges, it's the number one task I've ever had to do, and it was a thrill to be a part of it. Bill Allen, I pleased with the confidence he had in putting me in charge of it. I worked with a fabulous group of people in designing and building it. It's been a wonderful experience.
The visionary deal struck between Bill Allen and One Trip in 1965 has undoubtedly paid off in a significant and lasting manner, solidifying the 747's place in aviation history.
I think if Bill Allen and One Trip, and I assume they're looking down from heaven at us now, are saying, well, I told you so. I mean, they both were guessing this. I mean, there was what we thought was a great risk for those fellows. They were just smarter than we were. They knew it was going to work.
Rising out of the flat desert sands in Edwards, California, is a giant metal structure standing 100 feet tall and almost 100 feet wide. It's made of industrial-strength steel that could withstand the harshest winds and rain. This monolith of the desert, located at NASA's Dryden Flight Research Center, has been an unsung hero in the life of the Space Shuttle program for the last 34 years. This steel giant is called the Mate-Demate device, or simply the MDD.
6 inches. But it moves 3 inches forward and 3 inches out, and that's the only adjustment you have to set it on top of the 747. You can't move it any more than that.
You gotta remember that thing was built to lift 330,000 pounds. See a shuttle up close, you watch it take off on top of that 747 when it leaves here, and it's just amazing. You know you had something to do with it.
After the shuttle makes its grand re-entry, landing safely while the world looks on, and after the media has shut off their cameras and gone home, a vital, albeit less glamorous event is just beginning. The processing and mating of the orbiter in the MDD. After landings at Edwards Air Force Base, the MDD is used to hoist and attach the shuttle orbiter onto the shuttle carrier aircraft. so that it can be flown back to NASA's Kennedy Space Center in Florida. While simple in concept, the execution of this task is anything but. Considering the average landing weight of the shuttle is roughly 230,000 pounds and holds research and payloads acquired in outer space, precious cargo indeed. In addition to mating the orbiter to the shuttle carrier aircraft, a modified Boeing 747, the MDD is utilized to process the shuttle, a week-long procedure that includes taking up the landing gear, attaching the tail cone, and literally battening down the hatches.
They have what they call escape operation, and that's when they do the actual defueling. And the people that are doing the defueling, they have to be in a full suit. It's air-contained, self-contained, everything has its own air and everything. It looks like the spacewalkers.
During the week of processing, the orbiter is lifted about 10 feet off the ground, while crews work around the clock.
That's the basic idea, is to put the shuttle on top of the 747. That whole process involves a week of processing to safe the vehicle to put it on the 747.
Just before landing at Edwards, Kennedy Space Center deploys about 120 people to Dryden to process the orbiter. Together with the Dryden team, this highly specialized team of engineers, pilots, and ground crew work in unison under harsh conditions, performing precision, high-risk tasks with a fragile 100-ton spacecraft.
If you don't do your job and do it right, there's always something that could happen that could lead to somebody getting hurt, harming in the shuttle. So you have to make sure your job is done and done right, and with all the expertise that no one has. So, and that really what keeps you going is the pride in doing that.
Over the years, ground crews were able to perfect the art of mating and processing the orbiter, but never without risk and hardship. To fully appreciate the complexity and scale of this undertaking, it is helpful to understand how the MDD came to be and how it has served as an essential component in the success of the STS program at large. As the sun was setting on the Apollo space program in the early 70s, a new program, the Space Transportation System Space Shuttle, was dawning. One defining distinction between the two programs was that the Space Shuttle was a reusable spacecraft, unlike its predecessor. The shuttle, or orbiter, was to be lofted into low Earth orbit with the energy of 2 solid rockets and the orbiter's 3 engines fueled by an enormous external tank filled with liquid oxygen and liquid hydrogen. Upon its return from space missions, the orbiter would re-enter the Earth's atmosphere, flying without power, like a glider, and land on a long paved runway, like traditional aircraft. These methods of launch and re-entry proved to be very effective. With an extremely short wingspan, and without the expendable external fuel tank used for liftoff, however, the orbiter lacked the ability to take off and fly like a conventionally powered aircraft in the Earth's atmosphere. From the start of the program, engineers recognized that the orbiters might not be able to return to their launch site at the Kennedy Space Center in Florida because of an engine malfunction after liftoff or because of unfavorable weather conditions.
Shuttle can't land in the rain, no. Once it breaks through the atmosphere, it starts cooling off, and there's enough space between the tile that any water penetrating actually hydraulically pushes the tile off of the shuttle. The water doesn't have any place to go, so the tiles are just glued on. That's why landing at Kennedy, always concerned because, you know, how much rain it gets there. And we're usually pretty dry here.
In this event, a landing elsewhere would necessitate bringing the shuttle back to Florida, which meant the need for a structure capable of lifting the orbiter off the ground and placing it on the back of the 747 shuttle carrier aircraft. Using cranes to lift and attach an orbiter was deemed a far too delicate balancing act to sustain over the course of the shuttle program. It soon became clear that there was a need to build a permanent and reliable structure to achieve this task. Hence, the idea of the mate-demate device was born, and plans to fabricate and construct the first MDD were put into action. The Kennedy Space Center awarded a $1.2 million plus contract to the George A. Fuller Company, a division of the Northrop Corporation, to design and build the first mate-demate device. Soon after, the MDD at Kennedy Space Center was constructed in 1976. In the early stages of the Shuttle program, it was especially important to build an MDD at Dryden first. Assembled in nearby Palmdale, California, the first three orbiters, Enterprise, Columbia, and Challenger, were actually trucked to Dryden. Once there, the MDD would be utilized for the first time in the historic and groundbreaking Approach and Landing Test Program in 1977. The Approach and Landing Test Program, or ALT, was an essential component in the development of the Space Shuttle program. Used to validate the flying characteristics of the orbiter upon re-entry and landing, and test its systems in flight. The ALT program made use of the MDD for the first time to load and unload Enterprise onto the Boeing 747 in a series of high-risk test flights in 1977. In 1982, NASA arranged to have a permanent mate-demate device erected in Palmdale. The Orbiter Loading Facility, or OLF, was originally built for use by the Air Force at Vandenberg Air Force Base, where it planned to launch a shuttle for its own missions. When the Air Force canceled the plans for a dedicated orbiter and launch facility on the West Coast, the OLF was relocated to Palmdale.
Several years ago, they were doing refurbishment of the shuttles in Palmdale at the Boeing facility, and the orbiter would fly in on the 747, and they would fly into Palmdale, and we would offload it using the OLF, and then we would transfer the shuttle over to the Boeing folks, and they would do the shuttle modifications, and then, maybe a year later, we'd pick the shuttle up and reverse the process, put it back on the 747, and fly it back to Florida.
The shuttle orbits the Earth at Mach 25 and makes its landing at over 200 miles per hour. But when the orbiter finally comes to a halt on the ground, the massive spacecraft is not easy to maneuver. After landing, the orbiter is towed about 2 miles to the MDD, a process that takes over an hour. Once situated in the MDD, the orbiter is lifted off the ground and held there for days while crews work under and over the orbiter, preparing it for its return flight. Because it is not hermetically sealed, the cargo bay is kept at a positive pressure, and the electronics in the vehicle are kept operational. This ensures that the equipment and any experiments on and in the orbiter are kept cool throughout its stay in the MDD.
Anything that's in the payload bay stays there, because on the ground, the payload bay doors aren't capable of opening themselves. They have a special apparatus back at the Cape to hook into the doors to open it. The doors don't weigh anything in space, so they're driven with very small motors.
The MDD is an open truss structure, standing about 100 feet tall, with platforms every 20 feet. A horizontal unit cantilevers 70 feet out from the main tower units, guiding and controlling the sling-back hoist mechanism that attaches the orbiters to raise and lower them. 3 large hoists are used to raise and lower the lift beams. 2 of the hoists are connected to the aft portion of the lift beam, and 1 hoist is attached to the beam's forward section. The 3 hoists operate simultaneously, and they can lift up to 120 tons each. There are 6 stationary platform levels, 2 movable access service platforms, 1 for each side of the orbiter, and other smaller movable platforms.
The old MDD was gray and red. Now if you look down there, it's all gray.
In 2004, Dryden took on the enormous endeavor of removing the lead-based paint that covered the entire MDD. As part of a 5-month process, contractors blasted the paint off the MDD.
The job was huge. There was so much scaffolding and tinting. Once you get a hole in the tint, you had to stop operations. No more blasting until it was repaired, because there was some kind of positive ventilation inside the tent that kept the dust down instead of coming out. We were having, 4, 5, 6 days of 30-mile-per-hour winds constant.
By adding an ingredient to the blasting material called blastox, over 200,000 pounds of waste material was spared from being sent to a waste management site. Instead, the waste compound was sent to a Portland cement plant where it was burned in a kiln.
It's a zinc finish, self-healing, so if it gets a scratch, it somehow
corrodes and turns back into a zinc. It's an amazing stuff.
Don't have much to do with launch, but we know we got it back there safe from the last time, so always a sense of pride in everything.
Despite the intermittent landing schedule at Dryden, the support crew operating the MDD had an astonishing record of preparedness.
I like to think of myself as a good American for doing that. All my guys down there feel the same way, I'm sure.
Yeah, you need to step back at times and realize, wow, this is what I'm doing. It's just a small group of folks that do it.
Throughout its history, the MDD and its faithful crew had a 100% mission success rate over its 34 years of service to the shuttle program.
When I look back someday, I know I'll think of these times and realize just how fortunate I was to have worked on the program. And it's just kind of nice to know that, that you were part of something big.
Aviation, the art of aeronautics, began with the dreamers, inventors, and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth, and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.